Okay, so here we are on quiz number 3. We're supposed to find a bunch of stuff. Wants us to find the mean, median, mode, mid-range of the data. Alright, so here's the data set. And so basically you put it into your calculator, your TI. So on your TI calculator, what you do first off is you hit the Stat button. And then you'll be on Edit automatically. And just hit enter, because that's what you want to do. You want to edit. And then go to L1, over to L1, which you might already be up, and go up to the top where you're right on the L1. Like that. Cursor on the L1, and hit clear, the clear button on the right side, and enter. And that will clear the L1 list for you. So step 1, stat. Step 2, get on L1 and hit clear. So that'll clear the whole L1 list. If there was any old information in that list, it'll clear out now. Step 3, put that data down L1. So just put those numbers, 224, 204. Just keep hitting the down arrow. So just hit the down arrow every time as you put a new number in. I'm doing it right now as well. Put those numbers in. And okay, once you got them in there, hit enter at the end. Well, you don't have to hit enter at the end. Doesn't matter. Now, step 4, hit stat again. And go over to calc. And you'll be on one variable, which is what you want, and hit enter. And then hit enter one more time when it pops on the screen, and you'll get a bunch of data. It just calculated a bunch of stuff for you. First off, it told you X bar is 237.45. All right, and now we're supposed to round that number. See, it says round to one decimal place. So we'll make that 237.5. And then the median. Next comes the median. If you roll down on your data list a little bit, you'll see median is 224. Now mode. What in the world is... We're going to do the mode on our own. That our calculator will not tell. Mode means the numbers that occur most often, most frequently. So which numbers occur? Is there any repeated numbers, in other words? I'm looking for repeated numbers. 207, 207, that's repeated, and 224, 224. They're both repeated numbers. So you just list them both with a comma. The order doesn't matter. 224, comma, 207. Those are the numbers that occur the most often. That's a way of measuring the center. Like if you said, it works best for things like shoe size. Well, what's the average men's shoe size? You don't mean add them up and divide. You just mean which shoe size do men most frequently purchase, right? Most that occurs most often. So sometimes that's what we mean by average. Or if we say, what is the average number of kids per household in America? We don't mean add up the number of kids everybody has and divide by the number of families. We just mean, like, what occurs most often? Do most families have 2 kids or 3 kids or 1 kid, or what is it? So that's a type of average. And mean is the average where you add them up and divide. And then median is an average where you just grab the number in the middle of the data set. That way it's unaffected by really high or really low numbers. That's what a median is. It just grabs the number sitting in the middle. See, 224, if we put these in order from low to high, 224 would be right in the middle. So it's unaffected by super big numbers because you're not adding them up. So you'll see them use medians all the time in data sets for income levels, house prices, things that have really big numbers in the data set, because they don't want you to add them up and divide. Because if you say you had a $5 million house and a $300,000 house, and you added and divided by 2, you would say the average house price between them is, I don't know what, 2 million something. Well, this is a super crazy expensive house. So really we should just, put the numbers in order and grab the one in the middle. That's what median. That's what median is. All right, let's move on. Mid-range. What is mid-range? Well, first off, you got to find out what the range is. The range is the highest number minus the lowest. So what's the highest number in this data set? I think it's 308, isn't it? And what's the lowest number? Isn't it 187? You subtract those, you get 121. That's the range. We're not to mid-range yet. We're getting there. That's the range. That's how far the data set ranges. It ranges from a low 187 to a high of 308, like temperatures or something. The temperature today is going to range from a low of 60 to a high of 103. That's the range of your temperatures. So this is the range of your numbers. 121 is the range. So the mid-range would be like the mid-temperature. How would you find the middle temperature? If they said the temperature today is going to go from 187 to 308, that's a hot day. How would you find the middle of that? The middle temperature, the mid-range. Well, you would have to go halfway, wouldn't you? How do you take halfway? You got to take the 121 and divide by 2, right? In fact, let me just write the formula. The mid-range is going to be the low number added to the range over 2. The range divided by 2. Or it might make more sense if I write it this way. You got to take the range divided by 2 and add that to the low number, don't you? Because this gets you halfway added to the low number. So if I take 121 divided by 2, add to the low number, which was 187, I get 247.5. That's like the mid-temperature, the mid-range. Finally, let's look at these questions. I'm going to go to a fresh screen here. We can see them better. Okay, so remember what these are now. These are, what are these? These are weights of 11 players from a championship sports team. This is the best team in the league. They won the championship. This is their weight. This is how much they weigh. Okay, so that means D is our answer. The results are not likely to be representative. They're not going to represent all players in the league. Why not? Because the championship team is probably not typical. They're probably bigger, if this is football anyway. They're probably bigger. So this data does not represent all players very well, because this is not an average team. It's the championship team. Okay, on this one we're calculating GPA. So here we go. So they got an A in a 3-unit course. So we'll go grade and the points for that grade and times the units. That's how we calculate GPA. We're going to calculate GPA. So they got an A, which is worth 4 points in a 3-unit class, right? A 4, like a 4.0 is an A average. An A is worth 4 points, right? So the A is worth 4 points times 3 units is 12. Next, they got a B in 2 4-unit classes. Got a B and got a B, both 4-unit classes. A B is worth 3 grade points. This is grade points. So this again will be 12. 12, 3 times 4 is 12. A C in a 2-unit course. C in a 2-unit course. A C is worth 2 grade points times 2-unit course. That's worth 4. And a D in a 3-unit course. Got a D, 3-unit course. A D is worth 1 grade point. 1 times 3 is 3. Add these up. What do you got? 36, 43. So then take the total grade points, and you divide by total units. So that's going to be 43. Oh, what's the total units? Let me see, total these guys here. 10, 16 units. So 43 divided by 16, I'm getting 2.6875, and they want me to round it to 1 decimal place, 2.7. That's the answer to the 10th place. This is the 10th place. Right? First place after the decimal is the 10th place. That's where they want me to round it to the nearest tenths. 2.7. Here we go. Okay, so on to number 3. So basically, here, this is the top 10 annual salaries and millions of dollars of famous TV personalities. So here's their salaries, and they can ask me a bunch of questions. First off, it wants the range. Remember how we do range? Range is just high minus low. Like, what are the range of temperatures for today? From a low of 60 to a high of 105, right? That's the range. That'd be a 45 degrees range. So what's the highest number there? Is it 39, I guess? And the low, they go from high to low, I guess, so that's the lowest, huh? Just subtract those, and I guess you get 25.1. Now it wants the variance and the standard deviation. We're going to get those on our calculator. So I'm going to ask you to put data in L1 like we did back on problem number 1. So I'll just say C number 1 if you're confused how to put data in your TI calculator. We're going to use the TI calculator now. And put the data in L. Put this data all down L1. And then when you're done, get the answers. And what you'll get is you'll get a bunch of answers like this. You'll get X bar is 24.06. And on down you go. The one I care about is this one. You'll get S sub X, which is 10.43745.393. That one is the standard deviation. They want me to round to 2 places, notice. So I'll go 10.4. That's what S stands for. Standard deviation. That's what that S is. Okay, but then what's the variance? I'm probably not going to ask you for the variance on the test. I'll just ask you for the standard deviation. But the variance is the standard deviation squared, or times itself. So you just take that. Now, the problem is you can't use the rounded number. Remember in math, whenever you're going to answer a question, you can't use a rounded number, because that'll throw off the next answer. You have to use this whole thing here, or at least a lot of it. Not all of it. You could just like 4 or 5 decimal places would be good enough. So type in, 10.43745.393 and second power it. Do you know how to do that on the TI calculator? You have to go up arrow to enter. The up arrow? Right, there's an up arrow button. That goes to the power of the second. Enter. And I'm getting, so the variance equals 108.94. And that's the answer they want, 108.94 for the variance. And then their final question, is the standard deviation a good estimate of salaries for TV personalities in general? No. This is the these are the top 10 salaries. So this isn't going to be a good estimate of TV personalities in general. This is the top TV personalities. No, because these are not representative of the whole population. They're just the top ones. Right? If you said, I'm going to go on TV, I think I'll make somewhere between 39 million and 13.3 or 13.9 million. No, that's what the top people get. So this is not representative of the whole population. On to number 4 we go. They're wanting us to calculate coefficient of variation for waiting time. So there's basically these two banks are trying out two different plans for having people wait in line. Should they have everybody wait in one big line, or should they have a line at each teller's window, separate lines? And what they want is they want people to receive equal treatment. You know how you get mad when you go to the checkout stand at a grocery store or something and you get in the wrong line, and you've ever experienced that, and your line takes forever. There's somebody out there counting out their coupons one at a time and they can't even see, and they're doing all kinds of crazy slow things. And the other lines, everybody just whips in and out, and you're still standing there 25 minutes later. Well, that makes customers frustrated, and so banks want to prevent that. So they're going to do a study to say which is better, one single line or individual lines at each window. And by better, they don't just mean quicker. In this particular study, they're trying to they want to know how much variation there is, because you want less variation. You want everybody kind of to get equal, fair treatment. That way everybody will feel they've been treated fairly and not get mad. So you want less. We want less variation. That's going to make people be treated equally. There's less difference, less varying between the lines. That's the goal of this study. Okay, so they're having us calculate something called the coefficient of variation. How do you calculate the coefficient of variation? Let me write it over here. The coefficient of variation is the S sub x divided by x bar. See, it's the amount of, S sub x stands for the standard deviation divided by the average number in the data set. Basically, when you take standard deviation and you divide it by the average value in the data set, you want that number to be lower, because that, right, standard deviation is how much deviation there is in the data set, and when you divide that by average, you're going to get what portion of the average the data set varies by. So how do we get this? So it's pretty much like the other problems. You take this data right here and you put it in L1 on the TI calculator like before, and you calculate the stuff for it, and when you're all done, you'll find out that x bar is we're here. Actually, we're going to start with S sub x, I guess. S sub x is 0.46296, on, that's good enough. And x bar is 7.19. Then you just divide those, right, because it's Sx over x bar. Divide those on your calculator, and you'll get the answer, 0.064. That's the decimal. Notice they want percentage. What happens when we change an answer to percentage? You know the decimal moves 2 places when you put on a percent, so it'll become 6.4%. 6.4%, like that. And then you just redo that same thing. After you've done that one, you redo the same thing for the second line. Put it in L1 and use the TI calculator and do the thing again. And when you do all that, you get the answer 24.7. So notice there's more variation when you have at Bank B where they have individual lines. That makes sense, right? Because some tellers are faster, some are slower. You get more variation, whereas if you have one big single line, you get less variation, which is going to make the customers feel more fairly treated. It seems like the single line plan is better, makes people feel more fairly treated. Is there a difference in these? Yes, the waiting times at Bank A have considerably less variation than B. Okay, on number 5 here, the blood platelet counts of a group of women have a bell-shaped distribution with a mean of 263.7 and a standard deviation of 61.5. Now, what does that mean? That means that if you graphed the women's blood platelet counts, you would find a mean, a middle, of 263.7 and a standard deviation of 61.5. What does that mean, standard deviation of 61.5? That means that by the empirical rule, it says use the empirical rule. What we find out, empirical just means from data or from experience. So the empirical rule, what we've seen from experience, is that data that is what we call bell-shaped distribution or normally distributed, it's humped in the middle, right? Like most people are average, and then that's what the big bell shape means. Most people are average, the big size in the middle there, and then you go one jump. This is one standard deviation jump to the right. Here, let me and the left. Let me move that a little further, about right there, and about right there. Okay, that you'll find that you'll have from here to here 68% of the data either one jump to the right or one standard deviation, 1 SD plus 1 SD or minus 1 SD, as SD stands for standard deviation, which they're giving me right here, 61.5. So if I take this 263.7 and I add 61.5, right? Add one standard deviation to find this spot right here. The middle is 263.7. Add this, you get, 1, 5, 12, 3, 325.2, 325.2. And then if you take the 260, you can just do this on your calculator, and subtract the 61.5, you get, what's that, 0.22, 202.2, that's this spot, 202.2. So in other words, what we find is that 68% of the data, 68% of all women will have between 202.2 and 325.2 blood platelet count when the average woman is 263.7 and the standard deviation is 61.5. If you take that average value in the middle and you go one standard deviation jump to the right, add the standard deviation, and one standard deviation jump to the left, subtract the standard deviation, and get those spots, you'll have 68% of all people in that group. So that's the percentage there. And then next, and then I got to keep going. That's actually going to be number 2. Look at that, 202.2 and 325.2. That goes here. That's actually the answer to B. Then what's the answer to A? How'd they get this 140.7? What they did is they went one more standard deviation jump. So if you go one more plus one more, so add 6, and not, keep using that standard deviation, 61.5. Do it one more time, you're going to get 386 point. Wait a minute. Oh, I'm sorry. I'm not. Yeah. Oh, sorry. Here it is. 386.7. That's right. And if you so that's what this mark is right here. 386.7. And then if you go another one to the left, subtract 61.5 again, you'll get 140.7, which is that other number right here, 140.7. How much of the data is going to be in that region? Well, here's the rule. The empirical rule is if you go 2 jumps to the left and the right, you're going to get 95% of the data. So that's the answer that goes here. So the empirical rule, the rule from experience is this. If you have a middle, 263.7, and you have a standard deviation, if you go 1 jump left and 1 jump right, from here to here, you'll always have 68% of the data. If you go 2 jumps to the right and 2 jumps to the left, you'll have even more of the data. 95% of the bell curve will be captured. That's the empirical rule. So just know, if you ever have a curve, 1 jump right and left, that's going to get you 68% of the data. From the middle, 1 jump right and left. From the middle, 2 jumps right and left will get you 95% of the bell curve. This is just telling us how things work in life in general. Lots of things are normally distributed. Pretty much everything that occurs naturally. So the blood platelet count here, there's an average blood platelet count for women, 263.7. But of course, some have more, some have less than average, and that's the 61.5. That's the standard deviation. Deviation means, how far off the middle you are, how far off you are from average. So the standard deviation, the typical deviation or distance from middle, is 61.5 for women's blood platelet counts. So the average woman is 263.7, but some have more, some have less. The standard jump amount is 61.5. If you go up 1 jump and down 1 jump from there to there, which turns out to be 325.2 high to 202.2, you're going to get 68% of the data. If you go 2 jumps above the middle and 2 standard deviation jumps below the middle, you're always going to get 95% of the data for any data set. So these percentages, 95 and 68, will remain true for every data set that has a bell curve. There will be some average. See, the numbers on the bottom will change from example to example. So, for example, I could say men's shoe sizes. I could say, let me squeeze it in right here. The average man, I don't know what the average man's shoe size is. Let's say 8. But not every man's average, right? So that can be the average. Maybe the standard deviation is 2. So if you go up to 10 and down to 6, you're going to get 68% of all men have a shoe size between 6 and 10. But then if you go down another jump and up, and each of these jumps is 2. So we were at 8 in the middle, we went to 6 and now 4. 8 in the middle, we went to 8 and now 10. So if you go from a shoe size of 4 to 10, guess what? You'll get 95% of all men. So see how the percentages, 95 and 68, 95 and 68, those remain the same. We're just saying for any bell curve, if you've got a middle and you go 1 jump right and 1 jump left, you're going to get 68% of all the people. If you go 2 jumps left and 2 jumps right, you're going to get 95% of all the people. That's how data is normally distributed, bell-shaped distributed. Those numbers, 68%, 95%, are called the empirical numbers, the empirical rule. That's just usually what we find in almost everything occurring naturally. Men's shoe sizes, women's blood platelet count, men's heights, women's pinky finger length, anything you want to measure, it happens that way. 68% within 1 jump each way, 95% of all the people within 2 jumps each way of the middle. Okay, number 6 is a lot like, it's related to what we were just talking about in number 5. So basically a test, let's jump to here. A test is used to assess readiness for college. In a recent year, the mean, that's the middle, right, 20.5, and the standard deviation was 5.2. So we're talking about a bell curve again, where the middle is 20.5, and the standard deviation, which means the jump amount, right? 1 jump to the right, 2 jumps to the right. I'm not drawing that very well. In fact, I don't even have room to do it. Let me try it again right here. So the middle is 20.5, and we could go one jump to the right and left. How big is each jump? Standard deviation jumps are 5.2. So if you go up 5.2, if you add 5.2, not 0.52, just use your calculator, add 5.2, I think you'll get, what will you get? 25.7. And if you go this way, subtract 5.2, you'll get 15.3. That's this line and this line. So that's one jump each way. They're asking to identify the scores that are significantly low or high. How do you do that? Well, up here it says a value is significantly low if it's two jumps. That's what that z-score means. Z-score is number of jumps, number of standard deviation jumps. So if they're saying we want to go two jumps below and above, so then I need to go another jump this way and another jump that way. So that's another, add another 5.2. This will become 30.9, and then subtract another 5.2. This will be 10.1. So that'll go from right here, 10.1, and right here, 30.9 on that one. Oh, wait. I better read this more carefully. It says significantly low. This first one's low, and the second one's high. So the low will be test scores that are less than 10.1, right? All the scores that are down here below the 10.1, those are the lesser ones, and the test scores, the high ones, are the ones above 30.9. That's how they go, like that, right? The test scores, these are the low test scores. These are the high test scores. Why is that? Because a value is significantly low if it's two jumps. Z-score -2. And what is Z-score? Number of standard deviation jumps above or below the middle. So if your Z-score is -2, that's two jumps left, below the middle. And it's high if you're +2. That's two jumps right. So I started here, and I went one jump left, two jumps left. I subtracted 5.2, the standard deviation, twice from the middle number. And then I added the 5.2 twice to the middle number. And that's how I got my significantly low and high. So any score below 10.1 is significantly low. And any score above 30.9 is significantly high. Two jumps above or below is significantly high. Why? Because we just saw in the last problem that 95% of all people on a bell curve are between two jumps left and right, right? 68% are within one jump left and right of the middle. 95% are within two jumps left and right of the middle. That means almost all the people are going to be within two jumps. Almost all the people are going to be between this mark and that mark, 10.1 and 30.9. So anybody out here lower than 10.9 or higher than 30.9 up here, they're very extreme, very significantly high or low, because they're only 5% of the whole population. 95% are within the two jumps. So anybody above that or below that is significantly high or low. They're in the extreme 5%. Okay, we're calculating z-scores on this one. Z-score equals the score minus the mean over the standard deviation. So there's a good formula to put on your notes for when you take the exam, just to have that right in front of you for when we take exam number 1. So let's see, in a recent award ceremony, the age of the winner for Best Actor was 30, and Actress was 46. Here I'll use different. I'm going to circle the red for the min for stuff. For all Best Actors, the mean was that, and the standard was that. So let's do the min not mean, I did mean, the min z-score, which is going to be the score for the min, 30. That's the score. And this is the mean, minus 44.4, over the standard deviation, 7.6. So when you do that, make sure you hit enter when you're done with the top before you divide by the bottom. I'm getting minus 1.89. So that's the z-score for the men, the actors. And then just do the same thing for the women. I'll come down here. The women, it'll be, women it was 46. That's the score. The women's mean is 33.9. And the standard deviation is 12.7 for the women. So again, when you do this, hit enter when you finish the numerator and then divide by the 12.7. You know, you don't want to. That way you divide. If you don't hit enter, you're only going to divide the last number. The calculator will only divide the very last number by 12.7. You want the whole total on the top to divide by the 12.7. And I'm getting 0.95. So 0.95 on that. So which has a more extreme edge? Which had a more extreme? Which one of these numbers? Remember what z-score is. We just calculated z-score. What is it? Let's go back here. Z-score is the number of standard deviation jumps. So z-score is the number of standard deviation jumps above or below the middle. So the minus 1.89, that's almost minus 2. That means the man who got the award for Best Actor this year, being only 30 years of age, below the average age they usually get the award for Best Actor, he is almost 2 whole standard jumps below the middle, minus 1.89 standard jumps. Whereas the woman was older. She, how old was she? She was, 46 was the woman's age. So the man was 30, the average age for man is 44. So he's below. The woman was 46, and the average age for women was 33.9. So she was above, that's why hers was positive. She was above the average age, but not by a lot, not even 1.0, not even one whole jump above. So who's more extreme? The man who won the actor award this year. He's extremely younger than the average. So the actor, not the actress, is more extreme value because the z-score is a bigger overall number. Even though it's negative, it's a bigger overall number. It's further from the middle. It's further from 0. That's a good way to say it, right? Here's 0, minus 1.89, and here's 0.95, right? The min, the actor's age, he's further from the middle. He's further from average. Okay, so now we are on to this question. These are some cell phone airport data speeds for a particular network, like how long it takes their cell phones, or how fast their cell phones are. Find the percentile corresponding to 10.2. So there's the 10.2. And they're asking us, what's the percentile of that 10.2? Now, you've got to be clear on what percentile is. Very important thing to put on your sheet of notes for the exam number 1. Percentile equals percent of the data below. In other words, it equals number of data values less than your number over total number of data values. Okay, so let's figure that out. What is the number of data values that are less than your number? So we're doing 10.2. So how many data values in this list? Notice this list goes from the lowest number here to the highest number there, right? It's going in order. So how many numbers, what is the number of data values that are less than our number? In other words, how many are all these? Because all these numbers are less than 10.2, aren't they? All those data values are less than 10.2. How many is that? Well, there's 10 per row. There's 10 in this row, 10 in this row, 10 in this row. That's 30. This is number 31, 32, 33, 34, 35, 36, 37, 38. There's 38 data values less than our data value. And what's the total number of data values? There's 50, huh? There's 10 in each row. So if you divide that in your calculator, you'll get 0.76. Last thing, though, they want you to change to a percentage. Remember what happens when you change to a percentage? Decimal goes 2 places. So 76%, that's the answer. What does that even mean? That means the number 10.2, he is 76% of the way through the data set. That's what percentile means. What percentage of the way through the data set is that value? That 10.2, he's almost 80% of the way through the data. He's 76% of the way through the data. 76% of the data are below him. That's what that means. 76% of the data are below him. So it's the percentage of the data below. It's the number of data values below you divided by the total number of data values. There we go. So put this formula on your sheet of notes for the exam, for exam number 1. Okay, we're on to number 9 now. 9 and 10, I'm going to give you a process to help with this. It says use the following cell phone airport data speeds to find Q1, and then use some other data to find P90. What's it talking about? Let's go over here. So for number 9 and 10, find Q1 or P90. They're basically the same thing. First off, Q1, I should just put it right here. Q1 is the end of the first quarter. That's what Q1 means. And so say you're watching a basketball game or a football game and it's the end of the first quarter. What percent of the way through the game is it? 25%. 25% over, right? So that's going to be P25. That's what that P means. It means 25 percentile. So that's what Q1 is. So for example, what would Q3 be? It's the end of the third quarter. So if they asked you to find Q3, the game at the end of the third quarter, the game is 75% over. In other words, it's the same as P75. So the first thing I want you to realize is when they give you Q1 or Q3, they mean the end of the first quarter or the end of the third quarter, which is 25% of the way through the data or 75% of the way through the data. P25 means 25th percentile. Remember what we said percentile means? Percent below or percent before. So 25% of the game is over. Or P75 means 75% of the game is over. You're 75% of the way through the game. 75% of the game is below you in a sense, meaning below you in time. It's before you. Right? Okay. So when they say Q1, they're really saying P25. So these are both P questions. It's P25 and then P90 is the second question for number 10. So basically, how do we find a P thing? How do you do it? So since they're both P questions, to find P sub n, or let's just don't call it n, P sub, let's just make up a number right here, 25, for example. Here's what you do. Step 1, take that number, make it a decimal, and multiply it by n, where n is the, let me put it up here a little better. Total number of data values, and you get an answer. Now we're not done yet. Where you let's say you get a spot. Well, here I'm going to call it L just to help. You get something called L for locator. If L is a decimal, like 18.2, round up. Now I mean up, I don't mean off. So up would go to 19. So I'm not talking about rounding off. I'm not saying round it to the closest number. That's not what I'm saying. I'm saying round it up. Round it up. So 18.2 actually goes up to 19. Then find the 19th data value. And that's your answer. Now there's another option though. If L is a whole number, it's not a decimal, right? If L is a decimal, round it up. If L is a whole number, then find, so let's give an example. If it's a whole number, like 18 instead of 18.2, then take 18th. Okay, so I've written up some instructions for you to follow here. Let me explain it to you. So for number 9 and number 10, questions 9 and 10, here they are. Here's question 9. Here's question 10. So for 9 and 10, we got 9 and 10. So for 9 and 10, these questions, I'm going to go over here and give you some instructions. Basically, they're asking us to find Q1 and find P90. Well, I want you to see that these are really two of the same question. First off, what is Q1? Q1 means the end of the first quarter. End of the first quarter, like in a football game or basketball game. If you're watching a football game or basketball game, end of the first quarter, you know the game's 25% of the way over. You're at the P25 spot, meaning you're at the 25th percentile. Remember what percentile means? Percent below. So if you're at the end of the first quarter, 25% of the game is below you, meaning it's below you in time, it's over. If you're at the Q3, sometimes they'll ask you for Q3. What does that mean? That's the end of the third quarter, which in a football or basketball game, that means it's 75% of the way over. You're at the P75 spot, meaning 75% of the game is below you in time. So my point is that a Q1 or a Q3 question is really a P question. So when they ask you for Q1, they're really asking you for the P25. It's the same thing. Q1 is P25. They're the same thing because Q1 is the end of the first quarter, 25% of the way through the game. And then that's question 9. And then at number 10, they're going to ask us for P90, and so that means 90% of the way through the game. And it's not a game, it's actually a data set. So on this one, Q1, they want me to find the data value that is 1/4, right? 1/4 of the way through the data set. The data value at the end of the first quarter, like if you were to break this whole data set into 4 equal groups, what piece of data would be at the end of the first quarter? Or have 1/4 below it, I should say. And number 10, they want you to find the data value that's 90% of the way through. So looking at this 50 numbers, all these are 50 numbers. What data value is 90% of the way through that data set? That's what they're asking us for. Here's how you do it. I got a special formula. It's kind of complex. You're going to want to write it on your your full sheet of notes for the exam. To find a P, let's start with P25. That'd be Q1, right? That's the same thing. So to find P25, what do we do to find P25? Well, first off, we have to take the number they give us here, the 25, make it a decimal, and multiply it by n, the total number of data values, and you get something called L. L stands for locator. It's going to help you locate the right answer. So, but there's 2 ways you have to handle that L. It's kind of tricky. If that L is a decimal, like say like 18.2, then round up. But when I say up, I mean up, not off. Notice, don't round to the closest. 18 would be the closest. We go up to 19. And then you go find the 19th data value. Helps you locate. The locator tells you where to look. Go find the 19th data value. That's the one that'll be 25% of the way through the data set. But if instead L comes out to be a whole number, like 18 instead of, 18.2, it comes out 18, then you do something different. Then you go find 2 data values, the 18th one and the next one, the 19th one. And you take those 2 data values and you average them, meaning you add them and divide by 2. That's how you'll get your answer in that case. So there's 2 different scenarios here. The first scenario is if you get, so you take the number they gave you, make it a decimal, multiply by the total number of data values, get your locator. If your locator is a decimal like 18.2, round it up, 19, go find the 19th number in the data set. That locates it. But if it's a whole number, like 18, then take the 18th number and the 19th, the next number. Take those 2 data values and average them, add them and divide by 2. Let's try it out now on our question. So coming back to number 9 here. They're asking me to find the Q1, which is the P25, right? So what do? You take 0.25 times n, the total number of data values. Now, what's the total number of data values? There's 50 data values because there's 10 in each row. 10 here, 10 here, 10 here, 10 here, 10 here. Whoops, where am I at? I'm getting lost in the problem. Went to the wrong screen. Sorry. There's 10 here, 10 here, 10 here, 10 here, 10 here. There's 10 in each row, so there's 50 data values. If you multiply that, 0.25 times 50, you get 12.5. Now that's a decimal. That's my L, my locator. It's a decimal. So you're supposed to take 0.25 times n. Let's go back and look at the instructions. Right, 0.25 times n, and I got a decimal. So what am I supposed to do when I get a decimal? Round it up. Round it up. So 13th. So the answer is not 13. It's the 13th number in the list. What is that? Well, this is the 10th number here, because there's 10 in each row. This is the 11th number, 12th number, 13th number. There it is. 0.7. That is the data value that is 25% or 1/4 of the way through that data set. There it is. Let's do number 10 now. Same thing, we're going to take the 90, take 0.90 times n. Again, here we have 50 numbers. And so, what do we get? We get 45, which is a whole number. Now, what do you do when you get a whole number? If you get a whole number, like 18 or 45, take that number and the next number and average them. Add them and divide by 2. So I'm going to take the 45th and 46th numbers and average them. What are those? Well, remember, there's 10 numbers here, 10 here, 10 here, 10 here. That's 40. So this is the 41st, 42nd, 43rd, 44th, 45th, 46th. So this is the 45th number, and this is the 46th number. So the 45th number is 14.6. The 46th number is 14.8. What are we supposed to do? Add them and divide by 2. We're supposed to average them. Add them and divide by 2 because we want the middle. Because the real answer is right in the middle of those two. That comes out 14.7. So 14.7, which should actually be right in the middle of those two, is the number that is 90% of the way through that data set. That's the P90. Put all that information, put this information, or maybe this example, whatever you prefer, on your full sheet of notes for the exam number 1. Okay, last problem on this quiz. Basically, they want a 5-number summary of the data set. Well, that means take all these numbers. This will all be in our TI calculator. On your TI calculator, put L1, put all those numbers into L1, and then, hit Stat, go over to Calc, hit Enter, and Enter again, and you'll get a bunch of values. If you roll down the screen, you'll find 5 important numbers. It'll say min X, Q1, median, Q3, and max X. And what you'll have is your answers. That easy. 120, 125, 132.5, 149, and 150. Those are your 5 answers. Just bring them up here. 120, 125, 132.5, 149, 150. So those are your what's called your 5-number summary. And now we need to locate that on the graph here. So can you tell that it's graph? Let's see. Oh yeah, let me help. Basically, it's graph C because this is the first number. This is the 120. The second number is right here, which is 125. Here, I'll just put them right there. 125. This is the third number, which is 132.5. This is the fourth number, which is 149. This is the last number, which is 150. So basically the box goes between the Q1 and the Q3 with the median. What these 5 numbers are, they basically allow you to break a huge data set. We're only doing it on a few numbers here, but in real life they use this to break a huge, like 10,000 number data set into quarters. You're basically breaking it into 4 quarters, like a football game or basketball game. This is the first quarter. This is the lowest 1/4 of all the values. See, it ends at Q1, into the first quarter. This is the second quarter of the football game. It ends at the median, the middle, halftime. This is the third quarter of all the data values, ends at the end of the third quarter. And this is the fourth quarter, the highest 1/4 of all the data values. It tells you how your data values are spread out in 4 even groups by giving you 5 numbers. The very bottom number, the very top number, that's the minimum and the maximum. And then these are the quarter marks, right? Into the first, this is minimum number, maximum number. These are the Q1 and Q3 quarter marks, and this is the median, which means halftime, halfway through. So this is into the first quarter, halfway into the third quarter, very beginning, minimum, very end, maximum. And so the way you do it is you put the box notice goes between Q1 and Q3 with a line at the medium, and then you put this other, what's called whisker. Sometimes they call this a box and whiskers diagram. This line down to the lowest, up to the highest and down to the lowest, like that. That's the 5-number summary. There we go.